Hello and welcome back. So for today I have prepared another topic which is about how to implement an hysteresis in Simulink. So the background for this topic is this. When you have a fixed DT machine, you will observe that if you want to read some temperature from some sensors, you will observe that you have an oscillation, a temperature oscillation, and becomes more aggressive for higher temperatures. So this is only one scenario when you may need to implement such an hysteresis to get rid of the oscillations. So let's take an example here. We have an Excel here, which in this column E we have the temperature, which is the input temperature, and we output also a temperature but different values. So let's take for example this. So we have 20 degrees here, and we increase, yes, until we reach 23. So for this until here we will just output the temperature -1, yes. So here we can see that it will start to oscillate. So for this we want to preserve the last temperature, yes, until the oscillation with 1 degree is over, yes. So you can see here this is the desired output. Then we will just go on, yes, and then we will simulate this part when the temperature reaches a certain degree, and then it will start to decrease. Okay, and you see that for 24 we decrease, so we increase until 28, yes, and then from 28 we will start to decrease again, but again with some oscillations, and we want to get rid of this. So after these oscillations we will just decrease until 23, and then again one more oscillation, and again we will decrease until 20. So the expected output is here on the right, yes, and let's see what happens. So this is the input signal, yes. As you can see we have some oscillations here, then we will have an increase until 28, again some oscillations, and then a decrease, again one small oscillation, and then back to 20. So let's see how we can solve this. So we will just go to Simulink and create a model. I have it right here. Let's make some configurations. So we want a fixed step with no discrete states, and we assume that the sample time is 0.1, which corresponds to 100 milliseconds. Okay, let's start with this. So let's make an input, which is, let's say we have temperature input, then here's the input. We want to take a delay block, yes, a unit delay, and a relation operator. So we will check first how we can we want to detect the increase or decrease of the temperature, yes. Okay, so if the temperature actual temperature is greater than the previous, we will do something. Yes. Let's store here the actual temperature in this go to. Then we will want an if condition with two options. So first, if the actual temperature is greater than the previous at the previous sample time, we will execute u1. Else if we will check if the actual temperature is less than the, let's make here previous. Yes. Good. We will check this. If this is true, then we'll execute the second branch here. Good. Now let's move on. And I want to declare also some data store memories that we will use for two flags, which are first increase flag and first decrease flag. So I have data store memory here, which is first increase flag that we will use to detect if the temperature increased for the first time. Yes. And first decrease flag, same but for the decreased. Okay. Now if this is true, we want to make some actions. Yes. So we will make subsystem here, an if action subsystem. Okay, so this will be executed if the first condition is true. Yes. We will make another subsystem for the else branch, and then other subsystem for the so this one is for the else if, and this one is for the else. Yes. Good. So let's see what happens on the if. So what are the inputs for this? So we want to check if the first increase flag is the first increase flag. So this is one input. Then we want the previous temperature that we outputted. So this is the output temperature. Then we want also the first decrease flag. Yes. So these are the inputs, and the output will be the temperature. um, the flag increase, first increase flag would be and the decrease. And also we need actual temperature here as an input. Okay, so first thing that we need to do is to check if the first increase flag is different by 0. If yes, then I will take another subsystem here. If this is true, then the temperature will be actual temperature, yes, actual temperature plus 1. I mean minus 1 because we are increasing, yes. Okay, so this is here. So far we detected if the temperature increased for the first time. Yes. Good. Then, if not, we will take another subsystem. Yes. And just output the temperature we will just output the temperature, and the first increase flag we will store it like we will put 1. Like so. Okay. So first increase flag, this is out temperature, first increase flag, first increase flag out. Out temperature. Out. Okay. So far we have this. So if the first increase flag is different than 0, then we will subtract 1 from the actual temperature and provide the temperature. If not, the output temperature, the last output temperature that was outputted, will be just sent again to the output. And in the same time we will set first increase flag to 1 here. Okay, output temperature we will go on a merge because we have two conditional subsystems, and or this. Okay, and first decrease flag we will just send it forward. Good. So basically this is on the if. Yes, here. Then let's say first increase flag we need a data store read to read the first increase flag, and with the delay. Yes. Then the output temperature here. You will see from where this comes. The actual temperature and the first decrease flag, which will be 0 in this scenario. Yes. Good. Now let's move on the second block. If the temperature decreases, we will do more or less the same, but for the decrease part. Okay, so basically maybe I will just okay, so we have the inputs, which are first decrease flag, the actual temperature, the output temperature, and the first increase flag. Good. Then we will, as an output, we will have the temperature, the first decrease flag out, and the first increase flag. Okay, so again we will check here if the first decrease flag is different than 0, then we will have the actual temperature and we will add 1 to the actual temperature. Yes. Good. Then on the else branch you will have the same logic, but the output temperature will be just passed through, and we will set the flag first decrease. Yes. We'll write 1 in the first decrease flag. Yes, because we are on the branch where the temperature decreases. Yes. Okay. Good. Now let's make the merge between the temperature here and the temperature here, and output it in this output block. Good. And we will just init the first increase flag. This will be 0 in this case. Yes. Now let's go back and see. So we need again a data store read. We want to read the flag, the decrease flag, and with a delay. Good. Now we want to complete here the inputs with the actual temperature. Yes. With the output temperature, and the first increase flag that will be 0. So we initialize the flag with 0. Yes. Good. Now we are almost done. On the else branch we will just do an I will delete this one, and on this one we will just output the temperature like it is. So the output temperature gets output temperature. Yes. Then what we need to do is to make the merge between the first decrease flag init and first decrease flag out. Yes. So merge between this one and this one, another merge between first increase flag out and the first init, increase flag init. Then to store this in a data store write, yes, to connect this to the data store write, because we need to write this into memory. So first decrease flag and the first increase flag will be written. Good. Then another merge will be done between all the temperatures from these three subsystems. So a merge between this one, and this one, and just send to the output. Good. Then the last thing that we need to do here, it's where we just store the output temperature in the this. So we are using this output temperature here, but we need to store it. So I will just use an delay here, but with the external conditions which is the initial condition for this block, is actually the actual temperature. Yes? Good. Then I think we are almost done. Let's make a try here. So save it and see if compiles. Good. We change here this time until 2.8. This is because this is how many samples I have here. Yes. And make use of the signal builder. Okay, so I will remove this one, take the signal builder and connect. Good. Now let's go here and erase this column and also this one and import this. Okay, we select, replace, confirm, apply. Okay, so this will be the input for our implementation. Now let's close it and make a scope. So we will take a multiplexer and maybe we will keep this. So the input, the first input will be our implementation and the second will be actually the actual temp. And a scope. Okay, so I think we are done. Let's run it and see what happens. Okay, so as you can see here with the blue line is the actual input, yeah, before the algorithm, yes, and with the yellow one it's our implementation. So as you can see here, from here, from 0.3 already started to oscillate and we will preserve 22. Yes, then it will go up and will be kept on 22 until 0.9, and then it will just increase exactly like the input but with -1 degree until it stabilizes. So here again the temperature oscillates a little bit, and then we will just see that after it will start to decrease, our algorithm will also decrease the temperature, but with +1 degree. And then we will observe a small oscillation here, but the temperature from our algorithm will stay the same. And then only after another decrease it will start to descend again. So I think we can conclude here. If you have any questions or you see some mistakes maybe, or some improvements that we can do, please let me know, and have a nice day. Thank you.